across software development, product engineering. Also, currently he's a head of AI division in Footprint Limited. So, without uh, any further delay, let us welcome our session, and I welcome Mr. Rohit. So you can continue your session.
Hi, good afternoon all, and thanks for giving me this opportunity. So, as sir already introduced me, myself Rohit Shukla, and today's agenda and workshop title is basically agentive AI and generative AI, generative AI versus agentive AI, right? So, I'm going to show my slide. Just allow a moment. Yeah, hope my screen is visible to all.
Yes, visible.
Okay, great. So, the title is generative AI versus agentive AI, right? So generative AI basically a text uh, process. AI can create a text, um, an AI that act AI that react as a actor, right? And agentive AI, what is agentive AI? Agentive AI that assist you in your control. So the point is generative AI versus agent AI versus agentive AI. What is the generative AI and what is the agent and what is the agentive AI? We will in next few minutes or few hours we will discuss on around it, right? So generative AI, basically the creator, right? Create the content or a code or a model based on your prompts. So generative AI work on a prompt. How accurate your prompt, provide your prompt to the engine. Accordingly, the result is provided on the basis of your prompt. If your prompt is accurate, suppose you want to write a code or write a function that fetch the detail of XYZ in this kind of format, like table, like bullet point, like some XYZ design. So if you provided a prompt efficiently, the result will effectively provided by this system, right? Uh, Suppose we want to uh, generate a SEO code, for example, SEO code, right? Or some software or some function, technical function. So we need to say that in Chat GPT or something else in a tool that suppose to the engine. Suppose you are a 15-year or 20-year experience in a technical background and expert in architect design. So we need to say that you are a perfect or you are an architect or you are a technical guy. On the basis of this, next prompt is please design a database structure or please design some function for me. This is the requirement, right? So on if you say that Chat GPT or something else tool that you are that man, you are kind of at that level, 15-year or 20-year experience on you have these capabilities. After that, you can suggest that you could you wanted that this kind of a content. So it's same like as such in our mythologies in जब हनुमान जी को बोलते हैं ना कि आपको ये शक्ति आप इतने शक्तिशाली हैं आपको बताना पड़ता है वैसे ही चैट जीपीटी सेम एज इट इन चैट जीपीटी दैट you need to told that you are 20-year experience or you are a technical guy on the basis of he will provide the result accordingly. So the and generative API basically the game player is a prompt. How efficient your prompt is on the basis of prompt, the result is effectively. Sometimes in our development field, sometimes it happens that a code is or a task is basically 2 or 3 days, right? For a developer, for a senior developer. But again, the same scenario. If we build a prompt and involve our 2 to 3 hours, just write a prompt, efficient prompt, in a 2 to 3 hours, right? In 2 3 hours, the whole 3 days work is done within a 2 or 3 hours on the basis of prompt. Just minor changes we need to do in a system. Sometimes it's not required, but the monitor is required that the content is okay, the loop or maybe some database fields maybe mismatch. So we need to look that the content is provided by the AI, generative AI, is okay or not, right? So in this example, uh, a work log, basically a 3 days task, is completed in 2 or 3 hours, right? With effective manner, like within a error condition, within a try catch, and all the scenario that commenting and coding standard match, right? So generative AI reduce the work time, right, and effectively provide the result. These basically example for around.
Sorry to interrupt. Your slides are not moving. Are you moving or still?
No, I'm still on a generative AI.
Okay, okay, right, right. I thought.
No
Okay.
issues, no issues. So in generative AI, basically, I'm talking about some technical perspectives like code generation, but beyond it, the generative AI work like generate a text, generate uh, table structure, right? Something generate voice, or generate from your prompt, generate a voice messages, kind of, right? And what is the now moving on next section, that is the generative AI. Still on same slide. Generative AI basically the actor, right? That act what you want to solve the problem, right? So automatically execute the task and solve the problem within an environment. So agent that act for you, right? Suppose you want to complete some task like house cleaning, right? So now there are some tool that mop your floor, right? You just mark the point that will do the task, right? So that is agent AI. Suppose example, you are traveling to some city or some country like New York, right? And you want to book a ticket. You want to check the weather for next 2 week or next week. So what will you do here? You go on a Google and check the weather, check the flight ticket, and accordingly sorting that pricing or timing accordingly. But what if someone is doing the whole process for you? Like, you just say that just suggest me a traveling from this to date, this date to this date to New York. Just suggest me the weather and flight details, right? So a agent that act for you. He fetch the weather detail. He fetch the flight pricing, and sort accordingly, like timing or price basis. So single within a single action, you get the all the details, right? So these kind of a feature, this kind of a feature is called a agent AI that work for you, right? And what is the agentive AI? It's a third section. What is the agentive AI? Basically, agentive AI, that combination of multiple agents, right? So collaborate with you, augmenting your capabilities while you are remaining in control. So in the same example, I'm continue the same example. You are going to book a New York flight. So here I'm just checking the detail. Now, what if I want to book the detail and do my passport process, and many other process that involve in my journey. So in this process, multiple agents are work here. Like some agent, first agent will collect the detail of weather, second agent will collect the flight detail and fetch, and third agent will sort the flight and book your flight accordingly as per your convenience, right? And fourth agent will book a hotel nearby your location, if you suggested, right? And third agent will work for your passport process, right? So here multiple agents are involved, 5 to 6 agents are involved to done the process in chunk basis. First is fetching the weather. If you allow him that continues to check the flight detail on the basis of filter. If you allow that, then they book hotel for you on the provided nearby location, right? So these whole combination will work called as a agentive AI. Now we're moving on to the next slide. That is basically a roadmap. In a phase one, basically a generative AI. A phase two is an agent AI, and in phase three is an agentive AI. Now next slide. Again, the generative AI basically nothing is, it's basically a content, new content such as a text or image or a music base on a training database. So agentic AI work on a large trained database system, right? And what is the agentic AI? Agentic AI perform the task automatically and can pursue the goal by interacting within an environment, right? And AI agent control AI agent basically combine the generative AI and agentic AI. The capabilities access your complex object, right? For example, as we discussed in our last slide, book your flight or journey, plan your journey, right? So these are some basic features. So in a generative AI, nothing is it's work on your past trend, large trend data system, right? It will fetch the detail from if you're searching some news or some content, it will fetch the detail from multiple sources, right? And summarize detail will provide you on your screen, on your panel, right? Same in the agentic AI, perform a task autonomously and can pursue a goal interacting with the environment. And AI agent combine generative and agentic capabilities, right? So the decoding the umbrella of AI. So basically, AI is mm, umbrella basically is section-wise division. As a generative AI, it's a part of deep learning, and machine learning is basically whole combination is work as AI. So what is a machine learning? Machine learning basically a learning pattern, right? From the data like supervised, unsupervised, or reinforcement. For example, price prediction or spam filter. So ML is basically machine learning is basically a subset of AI, right? It's enable a system to learn from a data and identify the pattern and make a decision with a minimum human intervention, right? So in AI, basically in AI, basically three subcategories are involved here. One is a uh, supervised supervised pattern, supervised learning. Next is a unsupervised, and third is a reinforcement. So, what is the supervised learning? Supervised learning basically learning from a level data. This is a basic learning is it's a basically a predefined data according on predefined database. It react on the labeled database. And unsupervised learning basically are discovering a pattern by self in unlabeled data. And in reinforcement learning is learning through a interaction with the human environment, right? Each process has a unique characteristic, right? Each process means supervised learning, unsupervised learning, and or reinforcement. Each process has a unique characteristic, advantages, and real world process, right? So in supervised learning, basically uh, in supervised learning, basically a process that work on a level data based, right? So data that level some pointer, right? So for example, if I'm saying that a price prediction, right? So we are saying uh, in April, in Jan, in December, right? So in a suppose hotel prices, right? In December, so we labeled that in 25th of December, in 20th of December to 31st or 1st January, the prices will be goes on double or triple, right? So suppose some hotel has a price around $100 in a normal season. So in a New Year season or a Christmas season, it will goes on 300 or 350 $350, right? So these are some level pointers. So on the basis of level data, it provides the data on that basis, right? Unsupervised learning, like a data that without a label, right? That is unsupervised learning. So it's suppose like mm, for example, uh, uh, like face scanning, right? So in face scanning, first process is face recognition is basically a labeled kind of data where a pointer is already defined that your nose is in face nose is located on these area and eyes is located on this area and lips and other cheek is located on this area. This is basically a pointer, right? So your face is already point, right? uh, Face frame is already pointed, that is also provides. What if you're saying that recognize the picture image, right? Picture, suppose picture that need to recognize the number of a human, the number of animal, and the number of animal, what kind of animal, like in a picture that in a jungle, that a multiple animal and some humans, right, and some trees. So in picture that need to recognize that how much of animal are there or how much are human are there. So these these processes not this process not the level data, right? So in this process, in this process unsupervised, in terms of unsupervised, the AI will recognize how much the animal are there and how much the human are there. We will demonstrate in our next example, right? Just a minute, just a minute alone. So we will demonstrate in the next exam in an example in some demo next few minutes. What is the reinforcement? Reinforcement basically it's a combination of basically a state and action, right? So reinforcement basically work on a learning basis, right? There are some thumb rule in reinforcement. One is a reward system, one is a penalty system. What is a reward system? If the process is uh, going in a success way, right, that is a reward. If in a process some error, that on a penalty, that's called a penalty. In this process the flow will revise himself, right? For example, in a Tesla car, auto drive car, driving a car, right? Auto self drive. So when the car is drive, it go on a straight in a same lane, right? What if car is automatically change the lane, or car jump the red light, right? Or bumping or push the brake, right? So in this process, if the car going on straight way and stop on a red light, that is a basically rule. You need to stop on a red light, right? So when the car is stop on a red light, that is the reward point that it's worked properly, right? If car change the lane, first it should trigger the indication, right? that cart is moving on the right or left direction, right? So again, that's this the reward point. What if cart to jump the red light? That is basically a penalty point. So in this process, the system will report the data that these condition is failed. So system automatically reanalyze and redesign the system, and next time it will try to fix the issue, right? So this is a reinforcement process that work automatically, right? Build self automatically on the basis of penalty system. So the overall summary is basically ML is basically categories of supervised learning, unsupervised learning, and reinforcement. So in supervised learning, basically nothing is a trained data. Typically, problem on supervised learning basically uh, uh, used for clarification of task, like a spam email spam system. In our Gmail, you will check that there is some one section that's a spam or section, right, and a junk section. So some mail automatically move on spam tab, right? So the system recognize that mail contain this kind of a subject or this kind of header or this kind of IP, that will automatically route that mail to spam, right? So these are the level example, right? uh, Again, the hotel pricing example, right? In unsupervised learning, basically work with the data that has no predefined level, right? The model identify the pattern, cluster, and work independently. The key features of unsupervised learning, basically unlabeled data. There's a no predicted output. uh, uh, it's basically used on clustering a task like a customer segment, right? And associate a task with marketing bucket analysis. So for example, uh, in Amazon system, right? In Amazon system, there are multiple type of a user or a customer, right? Some customer have purchasing a household items, right? Some customer are largely purchased auto car system, right? Car system in their account, and some customer are largely purchase a clothes, clothes or BT systems, right? So system will automatically divide or move that user on that segment, right? First user will go on to a kitchen segment system. Second user will go on the car system. One third one on a closed system segment system. So when the sale or when a new offer is raised in Amazon, if the house if the kitchen system have any sale or any surprise sale in their system, the 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 Amazon will target on that segment system, right? So it's a basically use on a segment culturing system. And reinforcement, again, I already discussed. It's involve an agent that interact with an environment, right? A learning through a reward and penalty system, that maximum long term success, right? It's not a one day or a few hours system. It basically build himself by time to time, right? So uh, it's basically an agent that learn by taking an action, right, and receiving the feedback by a user or by himself, right? There is a no level data, no trained data. It's trained himself on the basis of error, right? So so what is a deep learning? Deep learning is basically a neural network based learning, right? For example, face recognition or self driving car, right? In face recognition system is basically uh, for example, a face and face recognition system is recognize face or attributes on, right? So there are, as I already shared an example, last example, that in a face recognition system, suppose in a metric system, attendance system, uh, they just recognize the retina that eye or located on that point, right? Nose on located on that point. So so on the basis of these system, it's work on handle with the neural system, right? On the massive data set, it's basically work on a massive data set, right? What is a generative AI? It's creating a newer content, right? Um, Content like a text or image or audio or a code by learning pattern from massive data sets via LLM, right? So moving on, next slide. It's a machine learning is a subset of we already discussed this. It's a where a machine learning is pattern like price predictions or spam clarification, right? Unsupervised learning uh, and supervised learning, right? And enforcement by it's basically learned by trial and errors, right? So it's a reinforcement. So deep learning is a basic subset of ML that use a neural network with a multiple layer of multi layers, right? It's a that sense are deep, right? Generating and handling image, voice, and large data set. For example, face recognition, right? Space, speech to text, self-driving car, right? Oh, generative AI basically create a new content using a data using existing data. Generative AI basically use a LLM, large language model, and diffusion models. For example, uh, it convert a text to image, convert text to video, convert text to code, convert text to song, right? You can see that the input is the text and output is image or video or code or a song. So um, in this example, a text is a basically a kind of a prompt that you're giving to engine, right? That suppose you create a suppose the prompt you're providing a prompt that create a image or create a moon image around a earth, right? So on this basis of a prompt, a image will a generative AI will create an image, a moon around the earth, right? So again, in the next example, from text to video, suppose you have you have some paragraph or some lyrics, song lyrics. You can create a video like a VO. In this VO, you can create a for example, birthday example, right? So suppose every day have celebrities birthday, right? So you can create a automation process where you can send a message or a video to your user, right? That today, suppose I'm Rohit, right? I'm a user and a system is sending a message that today is your birthday. Hi Rohit, today is your birthday, and today uh, uh, these XYZ celebrities is the same have today is the same XYZ celebrities have a on birthday or anniversary or kind of some kind of question, and the below a video is play that you both are handshaking, right? So these kind of some that's a basically example, right? So these kind of magic can do via generative AI in a text to code. uh, it's basically a GitHub Copilot. I'm using GitHub Copilot. In a next example is a text to song. Suppose if you have some lyrics and you want to create a multiple version, right? For example, you want to create a high note version or mid note or low note version of a same lyrics, right? So in Suno it's basically a website, Suno, or Suno.ai. When you provide the lyrics to in this website, it will generate multiple version of a lyrics, or 3 to 4 lyrics version. Suppose we have some song like mm, any song XYZ, right? So when we providing that lyrics to that tool, it will generate the uh, song that have high note lyric, high note sound, or low note sound, or mid note sound, right? So the magic is basically uh, from a text, uh, from the text, the magic is basically created on other form, is basically a image, video, or code, or a song. So in a development process, I'm just demonstrate you how the generative AIs work, right? So this was basically a VS Code. It's basically IDE editor. It's a VS Code, Visual Studio, and is a integration, right? Is a GitHub integration. So if I want to generate a page, a login page, right? So if I want to create a page, I need to a designer that create a page, build a CSS, and optimize that page on mobile version, right? On a desktop version, make sure that it will on a mobile version, and make sure that work on a large desktop version, or iPad, right? After that, I need to connect the page to my backend engine, right? What if all the process is completed done by a single engine or single tool, that is the GitHub Copilot. So I'm saying is here, create a login page, HTML page for me. You can see the code is automatically suggested. I need to just tab it for next, right? This is some example. We can also create a we can also generate the process without monitoring it, right? Or without tabbing it. I'm just prompting here, create a login page for me. Here I can also provide a prompt like, you are expert in a UI UX, like so create a page for login page for me. That will also work. So you can check that the process is working on. It's a login page, right? It's filled here somewhere. It's done, I guess. Where is it? Yeah, it is. Yeah. So now you can check that the code is generated, and here asking to keep it or undo, right? So if we undo, the code is clear. If we keep it, it accepted in the system. So now you can check here. It's make the header, make the title by himself. Use the CDN for CSS bootstrap, right? Right. The this is this is right. Now you can check. Now it need to check it in the system. That where is it generated? Yeah. So you can see that I'm just single line prompt that create a page. I hope a screen is visible to all, right? So you can see that I just single line prompt that create a login page for me, right? I'm not saying that create there is some section like email or a password, right? Provide me a feature that show a password kind of a feature, right? Remember functionality or forget personality functionality, right? Sorry, forget functionalities. So I'm just prompt that create a page login page. It includes all the involved process like validation, password functionalities like show password, hidden password, remember password. So in short, with a single line, it will work on multiple tasks, multiple scenarios, complete multiple scenarios, right? That will need to cover. If developer do it, first he create a page, then it make a validation or show functionalities or remember or forget functionality. Here in this process, the GitHub is done this for me within a few minutes or a few seconds. It will take around a 1 minute, hardly 1 or 2 minutes, right? With a minimum code level, right? You can check it. So again, moving on the back to the slide. So in the third point, text to code, it's a basically example how it's work in a GitHub Copilot. So next phase, how it's work in a phase one, basically a foundation. It's a basically collect data, right? And model architect training and fine tune with a human feedback, right? In a next phase, it's phase two, prototyping, building an internal agent and defining a tool, right? Defining a tool means for example, in my first example, what is the example? Yeah, flight booking. In first example, if you want to book my journey, right? So there are multiple process. One process is fetching the detail from weather detail or flight detail. So it's a basically initiator agent and defining what agent will do what kind of a functionality, right? Phase three, a vibe check, deploying a production for user and testing feedback, right? And cultivate. And phase four, basically a production, deploying the production agent and live monitoring and converting log into continuous improve the model. So you can check that in a phase one, go to the phase two flow diagram, right? In phase phase two go on to phase three. It will uh, continuously working on a like a user base user testing or a feedback, right? It's a basically a process that where a quality is improved by himself, right? In a phase four, it's a basically live. If the agent is deployed on a live server, it's monitoring himself and converting a log to continuously monitoring. For example, for example, uh, uh, in Instagram reel, right? In Instagram system, in Instagram that a reel is basically working on continuously, right? Uploaded on continuously. What if some engine or some flow is break, right? The system will break, right? So on this process, if any error or any maintenance action will trigger on that point, it will alert to the system that some process is not working as per as expected, right? So it will trigger the data on a first phase, and then again the process is executed from phase two, phase three. So it's going on the process, right? So it's AI production lifecycle. Review engineering, basically reviewing engineering on workflow. Core capabilities, basically natural language to code, real-time code assistance, as I already shared on my my code, my ID, right? That what is how it's work, right? Refactoring support, emitting a boilerplate system, impact by role if any junior developer, right? Creating learning by observing AI suggestions. So I'm again move my ID. First we complete the bullet point, right? In a mid-level developer, shift focus for repetitive tasks to system architecture, right? In a senior developer, utilize AI to review the code, detect a flaw and enforce the global standard. Specialist, basically focusing on heavily or a model integration or data pipeline or clean up a task, right? So in this example, we talking about a role-based impact, like a junior, mid-level, or senior. So in junior, it's basically learning by AI system. So if junior write a code, create login page for me. So if junior developer is work here, so he will start with the HTML tag. But what if the suggestion is provided here? He will learn how the HTML start, right? Like in this example, the doc type, right? So so when the AI is creating a content, it will start with the generate content doc type, and after that HTML language, en, head section, and link section, right? And body with a class, right? Form closing. So for junior developer, have some kind of a feature that he can learn that what will where the h1 tag is used, where the body tag is used, or where the class and what kind of a class in a bootstrap, right? If I'm no if even junior developer or a middle level developer here, it doesn't have any idea that bootstrap have a deflex class or a content alignment that already have in a bootstrap that align item in a center, right or left, right? So he will write some css or some class for making a content in a center line. So here the auto suggestion will provide you that these kind of a feature will how the div is used, how the button is used, right? So that error chances will reduce effectively. In a mid-level developer shift the focus to repetitive task to system, right? So in mid-level developer, he have an idea that suppose the form is used on a multiple pages, right? So he will create a, this section in a kind of a wrapper or a new page and include here that page, so that repeatedly or or added or the same functionality will be used on multiple pages, right? So senior developer utilize AI to review the code or detect a flow or enforce. You can here say that verify or you can I can say that to modify review. Here is a section review the code. So you can I'm checking here. It's working on. It take a few seconds. So here's a no problem is detected right now. Yeah, so some sensing it take a few minute. I'm going to modify it, right? Optimize the code and comment, right? What it'll do, you check, it's adding a comment and optimizing my code if any requirement is here. You can check that. Here the code for it's not formatted, right, and no comment in my previous example. But now if we going to keep this section, you can check it. Now the code is formatted, tabbing system is all work properly. First is a front, next tab is a head, and next tab is a meta, right? And you can check that centered container for a login card. Next card is next section is a login card. So commenting section already also suggested by AI. So it will help to mid level or a junior developer to what kind of how the code is written in a product based system, right? For a senior developer, he can review that where is the loophole, where is the functionality is missing. Even the testing is also performed via GitHub Copilot, right? So in a specialist, basically focus on heavily integrated integration and data pipeline or cleanup, right? What if we are in our product system, there are many times that the product is created or some features is created for some department request. After few months or after few years, that model is not in use or need to review that it's working properly or need to modify it. So on this kind of request, there is a one process we need to rebuild that process again from zero, right? Another process, just pass the prompt to the AI that please review the code or build this kind of a feature for me on this particular section, or link that this section to that section, right? So in first example, uh, development process is involved, right? It take three to it's depend on how work how kind of a work, right? It, minimally it will suppose it will take around 1 week, so for some task, right? What in another in a next uh, process with the AI within a few hours, right? Within a few hours, it will provide it will run the review and it will generate a code accordingly as per the requirement, right? So, so especially for the AI engineer, data engineer, it help to clean up the code, right? So it's basically how the AI impact on a IT sector on a role basis, right? So multi-agent system, basically the concept, a term of highly specialized is the AI agent collaborating seamless to complete a comprehensive task, right? For example, autonomous analytics system. Agent one pass the query, right? Plot the YDT stock again, right? And next agent is basically our task is generate a script required to fetch and format the data, right? A third agent is basically executor that execute your code, right? Run the code and generating the final visual plot and analysis, right? So in this example, the three agent involved. for visualize the YTD stock gain, right? So, in single line process, user or a front end user want to plot that YTD stock gain, right? But in this example, in this the agent AI, there are three agents are involved. First one agent basically fetch the user request, right? Next agent write the code, right, and fetch required data and format the data as per the request. And next agent will execute the code, right? So, in again, I'm moving on my IDE. You can check that. Suppose I'm passing the in first agent, I pass that write a login page, right? So first agent basically create a HTML content for me. Next agent, if I'm talking about the agent to agent wise, next agent will review the code for me and format that code, optimize and commenting on my code. And third agent will execute and test all the test cases, that what kind of a features or what kind of a loopholes are there. So in my example, first I write a prompt to my ID to the GitHub that create a login page. And second step, I optimize my code and adding a comment in my code section. In third step, I'll do the review or testing on my login page. So what if all the process is done by a single action, create a login page for me, right? So in this process, first agent will write the code, second agent will format my code and comment in my code section, and third agent will test and report the test cases or if any bug, right? So so and same example here, first agent is plot get the request, second example write the code, third agent is basically execute the code, right? Now moving on the next slide. So basically using limited of synthetic data generation, privacy in AI. Yes, the privacy is basically a bottleneck, right? Training advanced AI on a real user data process, significant complex and security risk, right? For this 100% local solution, you utilize a local MCP host and centric data SDV, right? So in this example, real data is requested by a user. Generative AI evaluates and visualize and project synthetic data to your as a result, right? AI beyond the hyper and cross industries. Uh, it's basically a product or a real base example. Like in a rental, Amazon recommended engineers that predict inventory and planning. Amazon basically a large it's a vendor that have multiple locations where the product where the order need to deliver daily basis, right? And you observe that in a million of in a million of order, there are only some thousands or some number of order reported that the order is not delivered on the same day or on a suggested date, right? On a planned date. So how it's work? No human can do manually that product need to go on to XYZ route, right? So it will, if the human are involved in this process, it will take a large human chain, right? And there's a and there's a 90% chances that number of 90% order will delay, right? So in AI, it in AI, what will do here? AI will basically a workaround like some product need, suppose example, order need to courier from Mumbai to Delhi, right? right? It's a fixed route, right? Mumbai to Delhi. It will take a flight courier flight on a day and on a night or one morning. The order will receive on a Delhi airport, right? What if what if any circumstances that route is altered due to some circumstances, right? Or by road there are some circumstances that a road is blocked, right? So if the human are involved, that in that process, the human, if the when the system is reported that this route is altered due to some circumstances, right? If the human some person are on a desk, it it will take a find the next route, right? And decide how it's work, and it will take a next step, right? Connect to the next hub or a next courier pointer, right? If the whole process is going on, he booked that courier to X to Y route, right? What if the human is on not on a desk, or it's basically off hours, so it will goes on a next day, right? So in this example, your courier will delay automatically 20 hours, right? 12 hours basically. Uh, Next to 12 hours, if the alert is going on off hours. So when here the AI or some engine are involved, automatic automation engine are involved. If the any route is halted due to some circumstances, that find the route possible route for the courier. So suppose example, a report route diversion is reported on 8 route diversion reported on 8 p.m. right? And the next 5 minutes, within the next 5 10 minutes, the system will analyze and decide where the route need to change, right? So in first example, it take around 12 to 20 hours to decide the what kind of a route they need to take, right? In next example, where the AI is involved, within a 10 to 15 minutes, the route is decided, and courier is diverted to X to Y route, right? So in first example, the courier delay is impacted on 12 to 20 hours. In the next example, no delay is reported. So in Amazon system, it's basically a work same kind of a feature, that it to predict that the courier from the XYZ distance take how much time, right? So in my experience in Amazon, hardly 5 to 10 times that courier are delayed. Number of times, maximum number of time, the courier delay as per the suggested time or date, right? As a provided date or time. So uh, in a courier service in Amazon, uh, AI basically work helping to deliver or inventory planning, prediction for a next sale pricing. What kind of a how if Amazon for example, why the big billion day sale plotted on a January? Why it's not on December? Why it's not on August? Because there are some predictions. The AI or deep learning or ML is working on behind that the January in 25th of December to January 26th of January, there is a large number of shopping. So when we uh, so due to this kind of a prediction, he plotted a big billion day kind of a sale in between or before or after these period, right? So it's basically a feature or that recommended AI to product, right? Manufacturing, logistics, predictive maintenance, UPSC route optimization. We already discussed saving a million fuel, right? Case studies, open AI rollout, modern utilization. AI fundamentally reduce vaccine development time, integration, and across R&D and clinical trial and marketing system, right? So AI native, basically new bank instruction like N26 or Monjo built AI first operation in the model automation core process like onboarding and fraud detection to operate a unique low cost, right? Automation trading system firm, small or high specialized AI driven firm execute a trade at a superhuman speed, analyze the data set to find a market opportunities invisible and traditional human desk. Emerging opportunities like compliance as a service, AI-driven monitoring offered on a subscription model, risk performance, advanced predictive tool, AI and blockchain, enhancing the transparency in a smart contract and a cross-border payment, right? So in this example, second type of trending trade farming. If anyone doing a trade system, right? I'm suppose I have suppose I'm investing my money in XYZ share, right? So I need to analyze that mm, the company or IPO is going on, right? How the price is going up or down, how the history is. So I need to check the all the details, right? Multiple search need involved here, but today the capabilities or system are provided that you just click on that button. In multiple website are providing this kind of feature that you just click on a button. He will just suggest you that this kind of a history of this here, right? uh, you need to purchase this or invest on this or not. If you are a long term investor, you need to, it's share is it's the XYZ share is good for you. If you are a long term investor, XYZ share is good for you. So it's a basically with a minimum time and with minimum effort, AI will provide you the report or a history that what is a good for you and what is a bad for you, right? It's your decision. You need to take again the human in a AI at the end point, human must be involved that what kind of process is going on, right? So at the end, the human interaction is must be there, right? So next point, testing AI. Testing AI basically uh, a key warning of a manager's like accuracy risk. The model may generate a high result to generate but entering an incorrect answer, right? Data privacy, if the private data inputting a sensitive or private data or a personal information into a public model, right? Content limitation, AI lack organization instructions. It may not understand a specific company culture or business context, bias and a fairness. Output is a mirror reflecting the existing bias embedded in a trained data system. Security is avoiding a sharing confidential company prompted. The golden rule, basically, overall realizes that dangerous. Always validate AI generated content with the expert human judgment. So so I'm again moving on to my last example. Suppose a system is change the route of any order. I'm a example basically Amazon order delivering system. Suppose a system is automatically change the route if any circumstances is created on some route. So in that process, I'm not in a favor that AI order system will automatically change the route that define the X to Y. Why it's not choose the Z? Maybe Z is a better, right? So in this process, the human approval or some human review system is involved, must be involved here. It maybe take some time. If your system is uh, uh, if system is uh, on the time basis, on the time to time basis, the system is basically capable to decide that x route is y route is better and z route is better. On that point, maybe 3 or 4 or 5 year after 3 or 5 years, uh, we believe that the system is working as we expected. But initially the human interaction must be, in all the entry points or exit points, that all the process is going on correctly or not, right? So these are the some key features or key warning for managers, right? Responsible for governance in the practices. For example, in a past history, the Apple Card study is basically a high profile example where AI algorithm were used for giving a woman significant low credit limits than a man, right? Triggering immediate reputation on a regulatory backlash. So in some news that Apple Card basically provide uh, uh, low credit limit to a woman in comparison to man. Where so and after that news, multiple news are reported on a against the Apple Card. So that's why the human interaction must be there before taking action or before going to apply the uh, uh, execution, right? Mandatory fairness testing need to explain why AI. It is no longer acceptable for AI to be a black box. Like a bank or enterprise must be able to audible justify exactly why decision taking. Like for example, why a loan is rejected, why the loan is provided for low credit limit to a woman, right? So there must be some checkpoints, right? Generative AI basically creating a content for you, right? A mechanism that um, next to token protections, right? In a first point, user provides some prompt LLM. In the next section, the LLM is transforming the text to as per your request, like a code, or a video or a audio, like or a image. So it will generate a output. So core definition, creating a content, new create, basically a create a text, image, code based on property or reactive. So a reactive writer unlock basically a strength. What kind of a strength? Extremely creative and fast, low cost and deploy, amazing data, idea and drafting, weaknesses, no tool or a real time action, forget concerns immediately. So strength in a strength, extremely fast. As we already discussed that if some task is developer doing some task in 3 days with the help of GitHub Copilot, it will complete it in a next few minutes or few hours, right? So involving a testing or a review system, right? Low cost deployment. You have amazing ideas. If you are generating any image with ChatGPT, you can check that what basic or minor point uh, that take when the ChatGPT when the AI creating some image, the single sometime we say that how the processes work, right? Suppose I'm prompting that create a universe image, right? I have no idea how the universe, right? But when you're prompting and AI generated that image, you can check that sometimes you can check that he consider all minor points that you never think about in a single go, right? So how it's work is basically it's not I'm saying that he is a perfect. It's work on a large database system. It improves himself by time to time, right? So amazing ideas and drafting. Sometimes basically um, foreign contents like nutrition, no tools or real time actions. This basically work on a database data system, right? It can predict for you, but no, not giving you a real time action, right? By yourself, right? Super talented intern who write a beautiful report but never click and send, right? So AI agent, it's basically a generative AI. A bot is AI. Agent AI automates the shift from prompt to output to goal to action. Now, generative AI prompt to output and agent AI goal to action, right? So in first example, suppose again we move on my first example. Let make make a travel plan for me, right? So this is basically a prompt. On the basis of a prompt, the output is a, uh, a journey plan, bullet traction, right? A goal action. A goal is basically travel from Delhi to like Jaipur, right? The goal action is book a cab or book a train, right? So say from prompt output to goal action. Goal definition: a single AI that decision and a reason that act using a tool, right? Like send in a picture that calculating the amount or sending a mail, right, or searching something on a on a web server, right, like fetching the weather detail, right, or fetching a flight detail or train detail for me, and calculating the price, how much if I'm planning a holiday for 1 week to some XYZ cities, right, city, the number of five people. So on the basis of my prompt, it will calculate how much amount will need to in a holiday plan, right? The secret source basically a React loop, a reason, and an act. Basically, is the combination of React, right? So in this example, there are reason multiply by two. Take thought. I have a thought that I need the population of a Delhi, right? So it trigger action, searching in a web server and a tool, and fetching the detail. Suppose, for example, it's provide some data like the 34 million, right? So 34 million, provide 34 million. In first example, multiply by two. So the final answer, the central final answer is a 68 million. So and you can check that one is a first phase is a prompt section, second phase is action, searching in a web or on some tool, and on the basis of a result on the data, it multiply the amount in two. So final result is 68 million, right? Super log. So analog, you lately intern, you give a clear instruction that and access to the tool and get it the job done. So in my example, as I started in a workshop, that the prompt is play a major role in a generative AI or an AI. If the prompt or a or a requirement is clear, right? So on the basis of a prompt or a requirement basis, on the basis of instruction, the AI is analyze what kind of a agent or what kind of a tool need to activate, right, to get the job done with a smooth manner, right? Instant, reliable, multiple step automation. Weakness: can a loop forever if a goal is work you. So you can say you are aware of that a looping system. If any loop is faulty, or any loop is basically have some errors, so it will goes on a infinite loop. Whatever infinite loop is done, it's execute without doing anything, right? Suppose we're inserting a data in our system by for some agent, right? So what if uh, uh, for example, in a last week I have a same kind of a issue that I just in my system I analyze mm, um, AI uh, camera action by AI, right? That uh, um, uh, check if any human uh, are going move forward, closing that gate, or doing some action, right? Suppose some action, right? So we need to do x, we need to call x function, else we need to call y function, right? But in my case, due to some error, uh, a loop is basically goes on infinite loop. So what is it will done? It basically insert a 20 million data in my database, right? So what is impact? It its impact on my database size. So it basically goes on a 10 G 10 10 to 10 10 or 20 10 GB, I guess. 10 GB data increase due to some error, that infinite loop within a within a few hours, right? So sometimes AI is basically a evil, some kind of a evil, if we are not monitoring or not proper using the alert system in there. In my case, I have alert system, but by chance I have missed it. So due to this, I face this kind of a data size issues, right? So again, back to the slide. Strength, reliable and multi-step automation. A weakness can loop forever if goal is working. So in left side image, clear instruction, tool access, can execute a task 1, 2, 3 and finalize the result. Like plot the YTT graph, right? Generative AI, a collaborative partner. Basically at the end, the human interaction. Suppose you have done all the work via some kind of a agent, right? But the end of the execution need some human interaction, need some human approval. For example, I'm posting my some post on my Facebook account, right? For this, I need to create an image. I need to write content. I need to decide the hashtag system. I need to decide what kind of a keyword is basically right now in a market, right? So a whole process, and at the end, I need to beautify the content, right? The whole process is take a single post submission. It take around a 5 to 6 days, right? But what if I do this task? Why some agent AI? Why some agent? I The agent will create an image and just provide a prompt that post the image on my Facebook account regarding a generative AI, right? So so first agent will create an image in Facebook post. There are some limitations or some guidelines. The image need if post image need to this kind of a size, or a content need to this kind of a limitations, right? So first agent will create an image, right? And next agent will create a content for me. Third agent will create a hashtag for me, right? And fourth agent will club all the content in one summarize section, right? And fifth agent will post the content to my Facebook account. So In first phase, I need to, if I'm posting the some post on my Facebook account, it take around 5 to 6 hours, 5 to 6 days, right? In a next phase, if I'm using a some kind of agent or some kind of a generative AI features, it will it will if I want to post a post in the next 5 minutes, right? I'm able to do it within a 5 minute, right? Now, if I'm using generative AI, so if I'm using a generative AI or agentic AI, I can post every 15 minutes a new post. So there, that's why nowadays we can check that multiple images, multiple posts or in a uh, uh, real kind of features introduced, that a same account or same user are posting a multiple images in a same day, different image, image or a different post in a same day in a multiple number. Initially, I have surprised why how it's work on, right? How the unique content is created, how the unique image created. Maybe it's maybe behind the picture there are some multiple large number of a team. But when I analyze, when I study that, I I found that there's a no team. There's a single human that's just prompt prompt just provide a prompt, and the agent is take a action again accordingly the prompt. Excuse me. So so that's how the system is work. Uh, Same multiple images or multiple posted on a Instagram or a Facebook within a minute or within a hour, right? So agent AI work user goal, AI process a plan or draft action, and then human approval is required. So that's why I am plotted here as a draw as a human gate. If a human is approved, the execution is the process is executed, right? So in my last example, if I'm posting a content on my Facebook account, uh, maybe there is a no human interaction. Maybe sometime some kind of a content or some kind of a image AI can post on my Facebook account that can block my account, right? So there are some I plot some checkpoint there. If I have when the process is completed, when the content is created, image is created, right? Basically, when the posting draft is created, the agent will send a message to my on my Telegram account. I need to check click on a approve button or a reject button. If I click on approve button, the draft will post on my Facebook account. If I reject on that action, the action will go back to do the back to regenerate the process, right? So that's why the human process is required. That's why the human gate is plotted here, right? Strength, safe, auditable, and build a trust. Weakness, slower than a full automation, require a human attention, right? So in a college at work, uh, editor send a mail using a Microsoft 365 Copilot, right? Figma BI basically they're generating a content or image, right? A cursor or a GitHub Copilot for writing a code, as I already explained to you on my ID, how it's working, right? Head-to-head comparison, basically a generative AI, agent AI, and agentive AI. Main job, agentive AI basically create a content, right? Agent AI execute the task, and agent AI act on your behalf, right? And automation automatically basically a none, nothing is related to generative AI. An agent AI is a medium, and agentive AI is a medium high, and a supervision. A tool is a no tool, In agent AI, yes, there is a React. In agent AI, yes, there is a user confirmation based on best for idea or some kind of a drafting system. Agent AI basically a routine job, right? Agent AI professional workflow. For example, generative AI example basically Chat GPT or Vimeo or Suno. Uh, agent AI booking or a bot. Agent AI booking a bot system, right? Or agent AI basically office copilot. Visualization the capabilities. Generative AI purely used for generation and generating a content, generating image, video, right? And agent AI basically as part of professional knowledge work order, right? An agentic, a fully automation system or autonomous term, right? The AI is a boss that he will do all the things for you that you want, right? So the key when to user with, right? To start, he will ask, do you do you only need content idea? If you are saying that yes, that will go to the generative AI. If you say that no, suppose you have a bot system, right? In a bot system, he asks that in a banking system, there are bot system, right? If you ask, if you said that firstly welcome, he asks you, how can I help you? If you're saying that I need to, my account detail, right? See, so when he fetched the account detail from his section, right? So on the same flow, suppose a tool that combination of a generative AI, agent AI, and agent AI. So when the user say that ask that what will ask, do you only need a content or idea? Uh, a trigger will to goes on a generative AI. He will next thing he asks for what kind of a content you want, right? On the basis of a prompt, a generative AI will provide the content to a user, right? If user is say that no, needs some action on a clear or respective task, and then so if there is a yes, then you then need to identify what kind of action need to take, what kind of a requirement is there. On the basis of a requirement or action, you use the agent, right? If again there are no, do you need a AI to manage the complex workflow while you are stay in a control, right? So when the multiple agent or a complex workflow are involved, then we use the agent AI. When we need to only generate a content or from a text from a prompt, we use a generative AI. When we use some minor or a restrictive task action, we need the agent AI, right? It is again some kind of flow diagram, how the flow is work on behind the picture, right? Picture. So prepare a data, creating a tool. In a first block, prepare a data and a tool, and a second block, designing the agent or build the agent, right? In next phase, quality check, right? In the next phase, if a quality check is if pass the quality check, deploy a deploy pre-production agent to the auto production, right? And then in the next box, user user test and a provided feedback. On the basis of the feedback on the test basis, it improves the process or it improves the code level, right? If a user receive any if system receive any user feedback or a test test bug, so it will report on a improve agent tool, right? On the and then improve agent toolbox or a improve agent tool agent will report that need to take some action, need to rewrite or need to do this kind of action, right? So evaluate as some agent to pass the feedback to the system to regenerate the process, right? If there is a process is going on, pass on the quality check, deploy deploy on a production agent, right? If the product, if some code or some products are deployed on a production, that doesn't mean that we need no we not do not need to monitor it, that it's work on properly. Maybe some error, maybe some error, maybe some data, maybe some kind of a feature that impact on my process. So there are always some monitoring agent, monitoring process are involved in every system. So if any error or any feature or any user feedback are received in a monitor log, it's convert and it's passed to the system. That system need to take some action, right? So first evaluate the set of and subject matter expert or to the level data, that what kind of an action need to take, right? So in this process, a, a single process or for single requirement, create multiple agents are involved. One first agent is basically building a tool for you. Next agent is checking your perform a quality check for you for the product, right? Third agent deployed your code to on a live server, right? And fourth agent is monitoring your system, right? So in this example, there are multiple agents are involved in this diagram, right? First agent is basically building your code for you. Next agent is basically performing a quality check, performing testing for you. Third agent is basically deploy your code on a server, right? And fourth agent is monitoring your code on a live server, right? So, for example, consider Instagram, right? In earlier days, basically, we did not have any kind of a real feature, right? Short video features. When a short video platform become a popular, right? Instagram introduced a new feature that is a real feature, right? Now, however, the question is important that did Instagram stop working when the real system was added in a Instagram? The answer is no. Did the developer shut down the platform or manually update every user account? The answer is no, right? So the the application continuously running while the developers introduce a new feature in a background, right? Once the feature is ready, it's simply released through a update on a platform system like on a Google Play or a Apple Store, right? what happened in the back what happened in a backend, right? When a developer introduce a new feature in application, several technical processes are involved behind the scene, right? Like a process, like writing a code, right? Writing a code for a new feature, right? So it's basically a build agent. Block is a 1B. Basically, writing a code for this kind of a feature, right? And next agent is basically involved for quality check, testing a code, ensure that it will work on a properly. Verify is there any loophole, right? And third agent will basically building compiling your application using a required library. If any library is missing or need to improve your process, he suggests that need to add this library or this need to add this code in this section. And third agent will deploy your code on a live server, right? So the whole process to introduce a new feature on our Instagram reel section, the whole process is basically smoothly going on and the live server without any failure. So deploying if a manually if you deploy a manually a one by one file on a or a one build deploy a build on a live server by one by one file, it will take a huge time. We need to he need to take a Instagram need to take some downtime, right? For this for the to complete this process. But uh, but uh, with the help of deployment AI agent, he just within a few microseconds, he just completely deploy your all code in a live server, right? In a repository, from repository to live server, right? Before perform the all the quality checks, right? So without any downtime, without mm, uh, any kind of a lag, the process is continuously smoothly working on, right? Sorry. Sorry. So in short, you see, AI basically in a large organization, developer do not manually perform all this kind of a step in every time, like code validation or code testing or compilation or a deployment, right? Developer are doing that job, but the basic validation or a loophole, unit testing, nowadays unit testing is for a developer is doing by a AI agent, right? So these kind of features that can help for a developer, right, to create a new engine, right? Now moving on next slide, there's nothing. This is basically a graphical representation how the AI perform on a backend, right? Suppose the developer basically pass a prompt that write a login page for me. Some agent is behind or working on it. Just pass your prompt or it will just connect the MCP server, right? And adding your data or reading your data to that server, and and if any database in interaction are involved, if we connect to your database, and according to your requirement, basically you create a content, right? Like example, as I already said in my last example, that I'm posting my post on my Facebook account, right? So for this kind of a feature, I have a table, right, where I just uh, added some prompt, right? Added some prompt that XYZ prompt, 100 of a prompts are there, right? So I schedule it on a daily basis. So in my prompt, a system agent will pick prompt from my database and create a content for me and posted the content on the to my Facebook, my Meta account, right? And this graphical same in the graphical representation, we receive a query, we pass the prompt and connect to the MCP server, right? Get the tool information. Now calling the tool, suppose we are searching that provide the weather of Jaipur. We connect the MCP server, get the tool information. Now call the tool, the weather API tool, and adding data into my local server on the basis of a content provide to response to the user. So MCP powered agentic, nothing basically. As I already explained you, my ID is ID GitHub. Now here's an example for the cursor. Whenever we provide a prompt that write a login page for me, he will connect to the MCP client, right? Contact to MCP server. Now find the tool, right? The basis of a prompt, it's basically a, if any content is from the web content, and to look on a web content, he goes on a web content. If any data need to look on what vector DB context. Now on the basis of a prompt, he decide what he need to do next step, right? So sending a context to MCP client, and MCP client responds to the developer or a user, right? Again, there are nothing, this the graphical representation as on my earlier slide, as example that plot a YTD slot again for Tesla or for XYZ company, right? So developer provide a content, provide a prompt that plot a YTD slot stock, where plot a YTD stock for gain of a Tesla. And if we receive the prompt, right, cursor, coding ID, right. So initially, in the first step, first agent will write a code. First agent will accept the prompt, right, and decide what kind of a this requirement, right. It will connect to the MCP server, right. And next, it decide the tool, what kind of a tool need to do. In my requirement, uh, the plotting the YTD slot. So first I need to connect the outside the API or a server web search, right. And next step, I need to write a code to plot a diagram, right, on the basis of a response API response, right. And the final need to plot the diagram. So in the tool, the system will basically parse the query to agent 1. Agent 1 parse the query and provide the data to the agent 2. Agent 2 will write the code, right, and pass after completion, the agent 2 will pass the code to agent 3 that execute the code to plot the final result, right. So the combination of agent 1, 2, 3 is a plotting a data for a user, that if all the process is going on a successful manner, is passed to the MCP server cursor ID response to developer or a user, right. What if any point there is a breakpoint or a error occur? Suppose agent 2 have some error, right, like agent 1 is not pass the data, right. So in that case, agent 1 will retry with number of a time, like if we provide a condition that only take a 3 to 4 retry, right. So the agent will try 4 times. If no success is received, if still the times after 5 retry or no success is received, it will pass the error message to developer or a cursor that need to change a prompt or need some more clear prompt to generate a YTD slot or gain for a Tesla, right. So in a voice agent workflow, a user basically nowadays I'm supposing that this Zoom call or a chat also recorded via AI, right. So if you want to summarize MOM, if in our meeting in a meeting before the AI, we just list out that what kind of what is the discussed within a meeting, right. On the basis of a discussion or noted down section at the end of the meeting, we just send a mail to all the users that these are the MOM of our meeting, right. But nowadays, I just record the meeting conversation, and after the meeting, I just use that voice to summarize or create a MOM for me and sending that MOM to all the users or all the participants that have in my meeting, right. So, but again, at the end of before the sending the MOM mail to user, I need to check that all the points are valid or as this need to send or not. So at the end, the reviewer must be involved in this process, right. So in this example, user pass the voice, right. For example, assembly AI speech to text transcribe the transcript to it, right. Creating a text for me, I'll involve invoking a right tool, and on the basis of the content or a voice, it generates a response, text to speech or speech to text, it's convert to speech. In this example, as earlier I said that Suno.ai where you just pass the lyrics. He just create a 3 to 6 version for your lyrics. Some lyrics, suppose one lyrics is a high note song version, and next is the low no note voice version. So these are the some magic AI that uh, can solve your problem or work for you, right? Again, this is a complex, some computer cursor and cloud desktop memory integration, graphical representation, right? So local centric data generation MCP, basically as in for security point of views. So web search, again a multi-agent, how the multi-agent or deep search work. A user pass a query, web search agent link up a web search, research creating a node for you, uh, analyzed agent work here, generate analysis report for you, bullet point for you. If note is approved, if note is not approved, if note is approved, the final responses will circulate to user. Again, as I discussed that then nowadays we use AI to sending a MOM, right? So in the example, firstly I'm upload the voice recording to a tool that receiver creating a note for me, analyzing the agent is analyze the voice recognition and creating generating a report for me, right? If I approve, I'm reviewing if all thing is going work for me, or if as per discussed in a meeting, I just sending a mail to the MOM, right, as a MOM, right? If something is need to alter or something needs to regenerate, I need to go again the from process one to, right. So these are the golden rule for the golden rule for AI, generative AI, basically creating uh, create for a creators, agent AI for others, agent AI basically help you do, right. So we move from AI that take to AI that act and AI that collaborate, right. So these just share to you some what just allow a moment. So as I said that I'm posting my post, right? So here's the image, here's some content, here's some hashtag. First part is the image, and second agent is doing writing a text on my image. Third agent is creating a content for me. Fourth agent is creating a hashtag for me, and final fifth agent is posting the kind of summarize the all the content on in a one window, and sixth agent is posting that content on my Facebook account. So I'm doing this with the help of N10 automation process. So here first agent is basically connecting to my database, right. Here I fetch the record from my database, a single post, fetch the first post that have a status pending, right. If post is pending, send me the message on my Instagram that this kind of a category, this kind of a description or a title, right. If I approve it, it goes to it change to my database is prompt status pending to approve. If I reject, it change the status approve to reject, right. Now in the next process, expect one record have a status approved status, right. If a post ID, if if the post ID is a blank or empty, right? So if a post ID is empty, it goes on the next step. We'll check that whether the image is the content is for an image or a video, right? If content is for an image, if the next agent is creating generating an image for me with the help of a Gemini AI account. Here's the prompt. You can check that. Creating a Instagram graphical representation in 9:16 ratio, right? Social media, penalties as clause. This a bottom section, right? You can check that. Last height is a 30% of height, right? So these you can check that the prompt is clearly described of what kind of feature or what kind of content I need, right? So initially it take some time to create a prompt, right? But at the end the result is impressively. Next agent in a meta, basically some guideline that the image must be in some ratio, right? So provide us a free size image, right? So we need to resize that image in a 9:6 ratio or some kind of x to y, x cross y pixel image, right? So next agent will resize that image, right? third agent a third agent is basically upload that image on some temporary location, right? And next agent is basically connecting my connect to my Facebook account, where I just integrate my Facebook account, pass my detail, that what kind of a API I need to do. I need a graph API, right? Authenticate my Meta account, right? Here the graph API, the fetch the account detail and posting detail to my Facebook account with the help of authorized token, right? The next agent is post image and content to my Facebook account, right? In this process you can check that the the approval process is basically here, right? That I've I receive a message, right? That I need to that please review the post before the posting on your Meta account. So I receive a content that this is the image, this was the title or this kind of a description, and these are the hashtag. So I review that all the content and hashtag and image. If I find that all thing is good and work for me as per Meta guideline, I click on my Meta account, my Instagram account that approve. It will go post on to my Meta account. If I reject it, it goes on reject status, right? So nothing will do on a reject scenario. So these are some basic use that I have used in working around a generative AI or with the help of generative combination of a generative AI and an agentive AI, right? So I'm done here. If you have any question or any kind of questions I have, I'm ready to receive or answer it.
Participants, if you have any question, you can ask in the chat. I think since there is no questions, thank you, Rohit, for this wonderful session.
Thank you, sir.
Implementation of multiple agents that you shown was wonderful, and I hope so. So session is recorded, so if any participants had I mean couldn't go through it through the whole session, they can revisit that recording again. Thank you so much, Rohit, for taking your time for this session.
Thank you, sir. Thank you all.
I would request you to send this lecture slide to me so that I can upload on the Canvas portal.
Of course.
Sure. Also, so next session will start uh, after 5 minutes, and thank you.
Thank you all. I'm leaving now.
Thank you, Rohit. Okay, so welcome back. We are here with our next session expert, uh, Mr. Devanjan Mishra, and he's a senior data scientist in Mastery's Ben's lab, Bangalore, and he will be taking about industrial applications of generative AI. So, without without further delay, I hand over to Devanjan. So, Devanjan, you can take this session and you can start.
Sure. Am I audible, sir,
Yes,
and visible?
yes, you're audible.
Okay. So, good afternoon, everyone. I'm Devanjan. As sir mentioned, I'm currently working at Mercedes-Benz Research Organization in India as a senior data scientist, especially for ADAS and generative AI domain. Uh, Currently, I have around 10 years of experience, professional experience, out of which around 7 years is in data science. And today I will be talking about uh, the industrial applications and how to actually go about uh, industrial applications in especially in the generative AI field. But regardless, this approach is usable across domains as well. So uh, I just wanted a quick overview of people and their understanding of Docker and Docker related components like Docker Compose and APIs. So, can anyone in the group just give me a quick overview of what your understanding with these topics is? This will help me plan the session accordingly. Based on uh, what you guys understand about these topics.
So, I think audience is aware about the generative AI because the some sessions have been conducted on it.
Hmm.
The intro about generative AI and the agentic AI.
Yeah.
Some idea about track-based system as well. Uh,
Uh,
about Docker and other technology, I don't think so. They have.
okay. Okay.
We can assume that they do not.
Sure, sure. Okay, sir. Then I will start from that perspective. Give everyone a quick overview of what Docker and Gen AI, how they're related, and Docker and APIs, how they're effectively used together. So I'll share my screen. Let me know when you can see. Is my screen up?
Yes,
Okay.
visible.
Yeah. So this will be the basic things that we will be covering today. So what are the requirements for any generative AI application in terms of deployment? Then a quick framework discussion, and then uh, one or two applications. I have the third one planned. So if there's enough time, we can go with the third. But I'll give you the code base anyways to try out the third one as well. So this will be the overall idea. So let's quickly go into the first one, which is the requirements for deploying any generative AI application. So as sir has just suggested that you guys are aware of RAG applications and basic Gen AI applications, but there's a difference in making a POC or making a proof of concept which can run locally on your system versus something which has to be deployed across multiple users, multiple time zones, or even for let's say a team of 20 who use different systems. Some use Mac, some use Linux, some use Windows. So how do you commonize your application, or how do you ensure that the performance of that application is same across and seamless in nature? So for example, you must have already experienced this. I believe it. We did experience this in our college, so I assume the same for you guys also. But basically something where you made some Python application, let's say, and you hand over the code to someone else, and they try to run it, and they encounter some error, and the classic response to that is it runs my system. So uh, to make this thing go away on a industrial scale, or on a real scale, on a scale where it actually matters and where it's a sentence of life and death for a company. These things have to be solved on a very different scale, and for that, uh, one of the primary use case is of Docker, and people using Docker for deploying any kind of app. So you must have heard about microservices. If not, microservices is uh, one of the key changes, or one of the key aspects of today's software technology, and that is primarily based on Dockers and APIs. So I'll quickly come to Docker now. What is Docker? It is a containerization platform. In simple words, what it does is it basically encompasses everything that a developer requires and packages it in one container. So you can view even this logo of Docker. It looks similar to a shipping container. So everything, whatever the application requires, OS, data, everything is provided to the Docker inside its containerized environment. It takes care of your application end to end, deploying that application, running that application, and whatever interactions it has inside, and whatever interaction it has from the outside world. So for example, if you want to provide data from the outside world, it should go in a very closed environment, and it should not affect the environment internally. That is a key idea around Docker, and it basically allows you to run an operating system inside a closed space. So you must have already gone through virtual environments. So how are virtual environments different from Docker? So virtual environment has host from the OS from the host, and virtual environment, and then there's application. So basically, you make a virtual environment and then you host that application on that virtual environment. When you give someone else, let's say a code base, you ask them to create a virtual environment and then install some dependencies and make it work. But that sometimes works, sometimes doesn't work, because the OS is it's not same or not configured same. So that's where Docker basically gives a edge to the developer. So here everything is inside, including this dependency, is inside the application. So you're really not worried if the whoever you have given the application to has the same host or not. Docker will take care of it. Docker will ensure that the dependencies are installed in the same way as it is on your system, and that's how it ensures that no matter where you are running the application, if it has Docker, it will run in the same way as it is running, let's say, in the developer environment. These are primarily the concentric circles, we call them, for Docker engine. And Docker engine is what basically manages your Docker containers, Docker images, data volumes, and network. I will not go into depth into all of them. Basically, networks enable us to enable this containerized environment, talk to the outside world. Let's say your data is outside somewhere else from where the Docker is deployed, then you connect it via networks, and you keep your data stored locally in a data volume, or you attach a data volume to the Docker, so that you can provide that data to inside the Docker for, let's say, the application to run. The third is image. Image basically is the main, I would say, the main building block of Docker, where you basically write out how the application will copy everything, run everything, and maintain its versionability, or maintain its data versioning also. Then there's container. Container basically these is the one which is used by the Docker engine to run this image. So ultimately, a container runs, and container various containers talk to each other via network, or via data volumes also, common data volumes also, and run different applications or different part of the same applications as well. Okay, moving on. So I think I've covered most of them, but a few other points. So isolation, as I already mentioned, it ensures that two applications are not uh, are talking to each other, but are not interfering in each other's um, functioning. So the way it is done is they have different isolation environments, and only their output or input will interact with each other. The second part is deployment, rapid deployment actually. So if you create a container for every process, it will not require a boot for an OS, and it generally, for example, for a virtual machine where you require a boot for an OS, the deployment is slower. Here, the deployment is very quick. So if you have the image ready, and if you have the image up as a uh, bringing the image up as a container doesn't take much time, and you can instantly start using the application as soon as the container is up. So getting the container up generally takes 5 to 10 seconds. 20 seconds is what I've seen at max. Beyond that, it doesn't. But doing the same thing from a virtual environment perspective is very difficult. And from a VM, it is not practical because it requires a boot of OS. Security, as I mentioned, it's since it's a closed environment, the permission of granting the control is entirely up to the developer. If he wants to expose a specific port, he has to mention that specific port has to be open for a specific application. So it ensures that we are managing the ports, we are managing the data movement and the traffic flow across the Docker. And scalability. So let's say your application currently only serves 5 people today, and if you want to scale it up to 20 people tomorrow, if you don't have Docker and Kubernetes, then it is very difficult because you have to ensure that you have a bigger serving memory, and you have to vertically basically scale up the memories to ensure you are serving all the customers all the time, even if the customers are not there. Let's say the peak was 20 and it reduced to 5 now, then also you will have to use the same amount of memory otherwise, if you don't use Docker and if you don't scale using Docker. So it ensures that you are able to scale up the application as and when the demand peaks up or peaks down. So it kind of serves as a good, um, I would say, price point. From price point perspective, you only use the compute which is required. You don't spend more on compute if it is not required, and you are able to get to the compute you're requiring if the application user explodes or the demand explodes. Any questions till this point? Anyone? Am I? I want to know the general idea how it is going currently. Any questions? Any suggestions? Any points? Anyone?
Any questions, participants?
Uh,
So I think no questions. So we'll take it
okay.
as to move ahead.
Sure. Okay. Yeah. Then 1 second. Let's go back. Okay. Yeah. So these are the basic Docker commands, I would say. 1 second. Let me share again. Yeah. Okay. So These are the basic Docker commands which are mostly used. There are other commands which are not that frequent. So the ones which are mentioned here are the most frequent ones which we use. Uh, so it starts with Docker build, where you build a container from a specified Docker file. A Docker file is nothing but the expression of a Docker image. And then there's Docker version. If you want to run a particular image as a container, so and this Docker run command comes into picture. Then Docker PS basically lists the number of running container that you have. PS minus A shows all the current running ones and the exited ones. So exited can happen where you have, let's say, defined a memory of 200 MB to a application, and the application requires 256 at its peak. So the container might die with the out of memory error. So you have the exited containers in that case. You can stop a container by a Docker stop or kill a container. Let's say if you want to stop some execution, you can kill the container itself. Docker pull, basically, just like GitHub repo, we have Docker repo also in-house, for example, for a specific company, as well as for your Docker Hub as well, where you can pull the images from a Docker repository. Same way, you can push an image to that same Docker Hub repository using Docker push. RMI basically stands for remove image. So it removes the image from local. And then you have, if you want to stop a container, you have delete a stopped container. So these are the primary Docker commands that we currently use, are mostly used. And these ones will be the ones which, will be the most frequent ones for everyone. Okay, now coming to the second topic, which is APIs, basically the application programming interface. So this is where the communication between applications starts. So let's say if you're running an application for uh, giving a login to someone, and and then the second part of that application basically allows you to, let's say, add some materials to your bucket list or something, let's say related to shopping, or if you want to do some computation. So one application is a login application, the second application is your compute application, uh, and third application, let's say, it's around uh, buying that application for you or buying that game for you, right? So the way currently we do things is we define applications based on specific business condition, and these applications talk to each other using APIs. So let's say you have done the login, you have made a login application. Um, the user provides his user credentials, login, and password, and the application basically ensures that they are both correct, and then kind of gives you a go ahead. Okay, yeah, this is verified. This user is verified. Then what will that application do is send a token or send a session ID to the application part, or the second part, which is data processing, or let's say where you are going to add things to your bucket list or to your watch list, right? So the second application basically takes input from the first application if the user is verified and has the credentials. So the credentials passed from the first application to the second application. The auth basically passes from the first application to second application using API. So the first API is deployed in a separate container. The second API is deployed in a second Docker container, and they both talk to each other using APIs. And generally, these are the two primary things that we do. We have a consuming APIs, where you send the request and to an external API, like let's say a weather service or GitHub. The libraries used are request, HTTPX, AIO, HTTP. So you can do a import request, give the URL of the API, and give the input what you want, input data, and it creates basically, right? and then you have then you can make your own APIs as well. The currently the majority uh, driven the framework which majority is driven is Fast API and Flask. So Fast API is the one which is currently highly in demand, and people are basically making most of their APIs on Fast API. And then you have Flask also, which kind of serves the same purpose. But yeah, these are the two ones. I've given the example of Flask here. So this one is consuming API. So if you want to consume an API, let's say GitHub API, you can do this. And if you want to, let's say, build an API, then you can do this thing from Flask import and make a Flask app, and then make this endpoint, status endpoint, where it returns the status if it is running or not. And then you can run the API like this. So a very quick way to make an API and deploy it locally at least. So 000 basically is the uh, uh, local host, and you can deploy. I mean, this application is deployed. So this is the way we generally make or consume an API. And coming to the big picture now again. So how does container talk to each other? As I mentioned, by an API, and this entire environment or this entire architecture is basically managed by Kubernetes. So Kubernetes is the final piece in the deployment puzzle, I would say. Kubernetes is the grandmaster who manages everything from container to APIs and ensures they are talking to each other correctly and as per the requirement, and only as per the requirement. So the first case is microservice architecture, let's say. Yeah. So each microservice, let's say this is a Python application, it will be exposed, or its output will be exposed. Only a single port or two or three ports will be exposed from this container, which will talk to, let's say, some another container, a Docker container of any other type, let's say a JavaScript, and only the exposed port will be given here, and they will talk to each other API. And this entire thing will be managed by Kubernetes. So the way Kubernetes will take care of this is, let's say today the number of users is less, so you don't need that many instances of container A. um, but tomorrow, let's say you have 2000 users, and only five of them, let's say, are actual users, and let's say rest are fake, or there's an attack on your service, let's say, right? So what Kubernetes will do is only scale up container A, make multiple copies of container A, and then all of them will only talk to a single container B, because the number of requirements to container B, or where the second part is happening, is very less. So if, let's say, the number of valid users also increase, let's say they also go up to 2000, then in that case Kubernetes will also scale container B and make multiple copies of container B as well. And let's say once the event of that spike demand has come down, and the number of users have normalized again to, let's say, 20 or 30, then it will kill the extra copies of container A and extra copies of container B. So that's how, based on the requirement, based on the demand, Kubernetes scales up or scales down your application. It is what is basically used in Amazon, all these big services companies, you name it, everyone has it. Every single company which has an application serving millions or even serving thousands of customers now have a Kubernetes. So it's not a question of if the company has it, it's only a question of how much is it embedded in their system. So some systems where, let's say, you only have 100 users at max, there it is fine to not have Kubernetes and have these applications deployed independently and talking to each other independently. But if you have more than, let's say, 100 or 1,000 users, and the demand forecast uh, is not predictable, then in that case, Kubernetes will always be there as a top level architecture layer, which basically controls or orchestrates your container at this point. And as I mentioned, all this communication is happening over APIs. So APIs is the third connection between this deployment and its application in any AI or any, I would say, related or software architecture related problem as well. Okay, I've covered the basics. And now I would request all of you to um give 1 or 2 minutes to yourself. Um, I would uh, I would take a break of 1 minute. I will come back. But basically, this is till this point I have covered the three building blocks that are required for deploying any large scale application. And after 1 or 2 minutes, we'll start with the actual APIs or actual use of these frameworks. I'll be back in a minute. Uh, Thank you.
Okay. Devanjan, you're not audible.
Sorry, I was on mute. Okay. Okay, I'll go again. So now we started with Olama, basically one of the frameworks to use open source LLMs, and this is their website. So you can download a Olama framework locally on your system. It supports all three: Mac, Linux, and Windows as well. So you can download it, and then you can pull up the models. So these are a few of the open source models that you can see here. You have Quen, you have LFM, Nemotron from NVIDIA, you have Quen 3 Coder. So coder specific models also, thinking models, tool based models, vision models, let's say the vision LLMs, VLMs, how we call it. Uh, all are available. Everything is open source, and many of these models have various size also. So let's say your local laptop has only 8 GB of RAM, then you can choose a smaller size model and go about. So this is the size mentioned here. So 6 GB size, 1.9 GB, the smallest one, and you can pull them using Olama Pull Quen 3 VL and uh, run it with Olama Run Quen 3 VL. Then you have Claude Code. You must have heard about Claude Code or OpenClaw. So you can use these applications on top of Olama as well, and basically give the LLM model as Quen 3 in this case to OpenClaw, again, which is on Olama, on top of Olama, basically. So this is the basic idea of Olama, and I would say this is a very good starting point. You can use YouTube and ChatGPT, Claude to understand how to run Olama models. There are companies which basically the entire POCs or their entire POC architecture or their entire POC strategies based around Olama models or Hugging Face models. So the second one is Hugging Face, where you have a lot of open source models, not just LLMs, but any deep learning model. I mean, if it is open source, it should be there on Hugging Face. So these are the primary two sources which are open source completely, and where you can download the models, play around locally, and see what you can build, or if there's an application which basically is in your domain or is in your research field. So you have these tasks, and for each task you have a list of models available. So let's say I only want to do text to image, basically convert the text into an image. I can go for text to image, and then you have image to video, image to image. You have all these computer vision tasks, not just limited to LLMs, but also deep learning models or VLMs as well, or vision transformers as well. Right. So this is a quick overview around Olama, and let's quickly see its features and why is it so useful. So as I mentioned, it supports many open source model. It's designed for simplicity, so it has a very the learning curve, and you can simply do most of its running using one line commands. um, Olama run Quen 3, and Quen 3 will be ready and up on your Olama interface in your CLI. The key features, so it is completely local. So if you have downloaded the model once in your system, then you can run it without internet. So there's no question of tokens consumed or API usage or anything like that. You can completely run it without internet as well. It's very fast, so it loads the model very quickly. It is slightly different from the actual models. They have a quantized model stored here, so all the models are quantized in nature, and that's why they load faster also on your RAM and are ready to go very quickly. You have multiple models, as I just showcased you. You have uh, multiple open source model, and most of the new models which whenever wherever they are coming from are mostly available on Olam, and it is very easy to integrate it with other APIs or other applications like OpenClaw or Cloud Code, as I just showcased. Why is it useful? I mean, I've given an industry perspective to you. It is private, so there's no question about the data leakage from the company to these giants like ChatGPT or Claude. It has no cloud cost, so the only cost is in running the models. There's no subscription or API charges. It is highly developer friendly. So if you want to test something, let's say if you want to test your RAG application very quickly and do a prototyping, then you can use Olama and run it locally on your system. You don't even need the Google Cloud or uh, OneDrive for that. It can run locally if you have good enough specs in your PC. And it has offline capabilities. As I mentioned, it works without internet. Yeah. Okay. So now coming to the industrial application. So this is the framework, and using this framework, we have two applications. One is the aspect-based sentiment analysis with a feedback and structured output, and second is documentation generation and code flow generation for code base. So I will try and cover both of them quickly with you guys. The first one is it's basically a superior version to, I will say, sentiment analysis. If you're working in machine learning field, and if you have I mean, you must have seen NLP's sentiment analysis till this point, and the various libraries which are used for sentiment analysis, and the structured way in which NLP does its task. The same thing you can do using LLMs also. So why is using LLM superior in some cases, not all cases? uh, Primarily, if you don't have a lot of background in NLP, and if you want quick wins, if you want to see the low hanging fruits, or where uh, NLP will ultimately shine, or can NLP shine or not, is where you can use LLMs. So it can basically tell you if the your what you're thinking can actually be made true uh, via LLM or via NLP. Uh, it has its limitations. Again, primary will be the computation. So running a sentiment analysis using a NLP models is way cheaper and way more, I would say, tightly design constrained and tightly executed as compared to LLM. But other than that, LLMs offer a superior understanding of text, which, if you don't have a very good understanding of NLP, even then you can use LLMs and almost get to the same level as a NLP model, which is well designed and well executed. So for this use case, I'm taking a sentiment analysis report. Basically, what we do is we have reviews available from uh, different restaurants. I'm using Yelp reviews, so it is again a open source data, and it has comments on it for different restaurants. So what we do is we use sentiment analysis to convert those reviews into stars, rating 0 to 5 from negative to positive. Now, generally, when you do NLP, you can do this task, and then you build a sarcasm detector on top of it and all those superior models. But here, you don't need to do it. It is out of the box able to understand the sentiment because it is trained on a very huge corpus of text. So, with sentiment analysis, you can ask the LLM to actually give you a rating from 0 to 5. Then you have phrase extraction or aspect extraction. So, for example, if you have mentioned things like slow service or great food in your text, now you have given some rating. Let's say you have given 4 rating out of 5, but you have also mentioned the service is slow. So let's say tomorrow the restaurant wants to know from Zomato that what should I improve to get my rating from 4 to 5. Then Zomato can do a key phrase extraction using NLP models or using the LLMs. So it can extract the phrases like slow service from the comments and tell the restaurant that, okay, you're getting 4 out of 5, but that fifth star you will get if you improve, let's say, your slow service. And that's how key phrase extraction actually helps in the business case. So you have sentiment attached to words, and it basically tries to understand that sentiment behind it. So if you are targeting a specific thing, let's say the restaurant asks Zomato, tell me about my service, how is it? Then using key phrase extraction and LLMs, and the Zomato can tell, okay, if your service is good, bad, in a word answer, in a description, in multiple sentences, all up to us. So we can do all of these things using LLMs. Then there's opinion mining. So you must have seen, now it is available on Google, but if you go to a restaurant and you just look at the overview, so, or if you go to Amazon for a specific product, you will see a key overview basically telling you about the product, that based on the comments that are mentioned, this product is good to use, has an okay finish, all those things. So basically opinion mining takes care of the subjective expressions that are there, which are very difficult for uh, I would say a novice or a new or a beginner NLP uh, developer to understand. So it gives you a understanding or a context to the opinions which are mentioned in the comments. So let's say you have never worked with automobile related data, or let's say if you are told tomorrow to build an NLP model which tries to go through the comments mentioned by customers for a car service or a car dealership, and now you're not aware of the words that are used in car dealership, like clutch, gears, all these things, lubrications, all these words. If you're not aware, then you will not be able to build a very good NLP model or a very good NLP service. But LLMs can take care of that opinion mining for you there in those cases. The second part to it is the standardization or canonicalization. Let's say if you want to map everything to 5 or 6 outputs. One, let's take the example of restaurants again. If you want to map the performance against few benchmarks, let's say the service, the food, the ambience, um, the reachability, the quality, customer support, and billing. Let's say you have 6 or 7 of these benchmarks that you want to test all the restaurants up across, right? Then uh, NLP will do that task for you. So NLP will basically categorize the comments on these benchmarks automatically. So it will automatically map diverse phrasing, like let's say slow service or the service was slow, to the same standardized label, which is service, and inside service slow. So it takes care, it makes your data very formal. So let's say tomorrow you want to build a predictor, or you want to build a regression model on top of your text data. Then you have standardized normalized values, you have normalized text or normalized labels, and then you can build a classification model or a regression model. So it kind of reduces the complexity of text into simple labels, and makes the job of, let's say, the next developer very easy. So if you give him the the raw text or the raw descriptions or raw reviews of, let's say, 10,000 customers, then he will have a hard time to build an NLP model to convert it into these benchmarks, because he has to look at each benchmark separately, service separately, food separately, build sarcasm detector in each, build separate canonicalization each. Rather, if you give it to an LLM will and ask it to make these to read the description or to write the description on these standard labels, it will be much faster, and it will basically make or give the entire raw text into a structured response or a JSON structured response. So the thing which I mentioned, the tools, right? So these tools basically enable that. They basically enable you to structure your response in a, let's say, in a JSON. So there are various LLMs which support this tool uh, calling, and one of the tool callings is a structured JSON response. Okay. One second. Yeah. Uh, yeah. The next point is information extraction. Again, this is another key idea behind using NLP. Is basically, if you want to convert your entire data into specific, I think I've covered this, but basically reduce the complexity in your text data into simpler JSON response, then you can use LLMs. So the example I will take you through is one second. Go to the example directly. Okay. Yeah. So again, this is an open source data. You can get the data from I think Kaggle. Yeah, it's available in Kaggle. So this is Yelp restaurant reviews, and here you basically have the URL for those specific restaurants, the rating which is given, the date, and the review. So if you go through a few of the reviews, you'll see that there's a lot of sarcasm in many of the comments. But I mean, the review size is also different. You have to do padding and all those things otherwise. And there's a lot of complexity in terms of the sheer number of ways it can be measured. In good food or in food also, you can have multiple subcategories. For example, bakery or cold food, shakes, all those things. So you have lot of possibilities with this text data, and then again, if you want to do it structurally using an NLP, you have to have a lot of understanding of these comments and how they are basically mentioned. The other way is you can use a LLM. So for example, this is you can run this locally, or you can run this from Google Cloud. But basically, this installs all the libraries that are required for running this. It also installs Olama. This one is basically a notebook which you can run from your side on Google as well. So it's again, it doesn't take a lot of memory, and you will be able to run it very easily. Then you just check if Olama is running properly by running this command, Olama sir, and it will basically tell you if the Ulama is installed and running correctly on your system. Then you can pull a model. I have pulled Qwen 3. You can pull whichever model uh, you want to use. Then pandas and all the other Python libraries. You also have to install Ulama, which is basically a Python SDK on top of Ulama, which allows you to run Ulama functions using Python in Python code. Right. Yeah. Then you have yeah, this is the one. So this is the Yelp review code or dataset that I have pulled in, and I just showcased you that dataset. Now, if I want to do a very simple analysis, it doesn't include dishes separately. A very simple analysis of how the comments are, right? Then I've written this code. Basically, it's a prompt, and simply what it says is extract the sentiment and ratings points from the following restaurant review. Return a JSON. So I want the output to be in the form of a JSON so that I can structure it and let's say pass it to a classification model later on. Rating integers 0 to 5, pain points, list of single words or short phrases if there's something negative in review. Avoid sarcasm. So sarcasm detection is taken care by these two words. Avoid sarcasm, and then list single words or short phrases, let's say bad bad roti or something, right? Then a simple phrase is good enough for me. And single words for good things also. So we just don't want to see the bad things, but the good things also. So this is what I've given as my output. So this is what I expect in the output. There should be a rating, pain points, and positive and negative positive points as well. The way the review will be written, so you will have I have called this tool. So this is the function tool, which basically makes it a function and returns the output as you get from a standard Python function. So the first is rating, which is has the type of integer, between 0 to 5, and then you have pain points, which is an array which is of the type string, and then similarly for positive points as well. The necessary one is rating. So for example, if some comments only has negative pain points, it doesn't have positive points, then also it is fine. Just give me negative points if those are only available, but always give me rating. So rating is something which is mandatory from each comment, right? So this is how you basically make a tool chain command for an LLM to execute. So what will be the input here, right? Let's come to the input part. So the way we will do it is we'll attach the input or the comment in this review, and then based on this review, the LLM will give us output. So till this point, we will get the output from LLM till this point, right? Now from this point, then we extract the output in our usable fashion. So we extract from the response, we extract the message if message is available. If tool call is there in the message, then we extract the output from the tool call and then basically store it as a result or response. So let's say I'm reviewing the ratings now, and limiting rows is what I gave as 50. So I want to see only for 50 how it currently is. Review and response, this function, calling the function, appending the reviews, appending the response, LLM response. We also append LLM response just in case to see if LLM is responding and we are not able to collect the output, or if the LLM is not responding, and if it is not responding, why it is not responding. So we also append the LLM response. This is review total, basically giving you pain points. If pain points are there, Positive points, for example, good ice cream, recommended cookies and cream ice cream. Rating is 5. Pain points, too sweet, sweetness, tolerance low. Positive points, nice little local place. Pumpkin shake, love pina colada, so refreshing. Banana split is good. All these are positive points. Rating 4. So based on the text, it has given you certain rating and positive and negative points like this. But if you can imagine if you have to go through NLP to build the same thing, right? It will be much deeper and much more uh, domain specific requirements. Same thing, you can, as I mentioned, collect the LLM response. This is just to see if the LLM is performing correctly or as expected or not. And I mean, not really useful if the LLM is performing well. This is just for debugging. Then you can save the response locally and use it anywhere else. Now, let's say if you want to see, now if a restaurant wants, I want to know which dishes are performing well, which dishes are not performing well. I want not just the pain points or positive points, but the dishes also, pain point dishes and positive point dishes. So there you add these 2 points, pain point dishes and um, the positive dishes. And then since it is more specific in nature now, we are also giving an example to the LLM. So if the review says the burger was cold but service was good, then the pain point will be burger, but positive point will be good service. Then you attach the review at this place, and then again you do the tool calling. In the tool calling again, now you have uh, two additional requirements or additional asks from the LLM, which are the pain point dishes and positive point dishes. And this way, at this point, you collect the response from LLM and then you basically filter out same as previously. Again, run the same loop, let's say for 50 comments, and then you have the output also. So as you can see, right, if you're using the latest models, and if you mention the prompt correctly, and if you are using a tool calling correctly, then it will always give you the response in a structured JSON if you have asked for a structured JSON. So in this case, it has given my ratings, positive points, negative points, everything. Let's just take this one as an example. Pain point dish was chocolate ice cream, and positive point dishes is also banana cream and chocolate ice cream. Great service. Rating is 5. So if the same thing is mentioned at both the places, this can be a good additional filter that you can build upon later or update the prompt later. Same thing, like this, you have collected 5 responses from the LLM, which are very specific in nature. Now, coming to a quantitative response. So, let's say if I want to generate a CSV, which basically will give me these values, right? And so that I can use it for later, I can save it as JSON or save it as CSV and store it. Now, if I want to combine and standardize the positive or negative reviews, right? Uh, if I want to map it, so uh, I what I will do is collect all the positive points, the pain points, and the negative points from all these comments. Here I've used 50. So for those 50 points, I have total 25 pain points and 61 positive points. Now I am going through all these positive points and negative points and trying to standardize them. So instead of me telling, okay, make the service as one criteria, make food as one criteria, make the ambience as one criteria, you come up with the standard responses or the standard benchmarks across which we can measure the performance of restaurants. So this is what standardization means. So even if you're not aware of how the restaurants work or how to judge a restaurant, this will basically standardize the labels or give you the benchmarks for that directly. So here we have what we are trying to do is map free text points to standardized feedback labels. So what the LLM will do is pick up few initial comments or pick up few initial pain points or points in general, not just pain, but good points also. Pick up few points, see if they are similar. If they are similar, it will basically classify and put it under one bucket. Then pick up the next one, next 5 comments, see if they are matching to the previous buckets. If not, then it will make a separate bucket for it. So it is basically doing a classification for you as you're moving along. Text classification, as you would say. And at the end of this, what you'll have is basically a structured labels or standardized benchmarks across which you can judge a restaurant. So for example, here it has given all these ones. Nice little local place. These are the points, pain points, right? And according to that, it has given a special, for each one it has given a standardized label. So nice little local place is local establishment. This can be a benchmark criteria. Local establishment, yes or not. Accommodating policies, accommodating, this again falls under accommodating. Allowed early ordering is accommodating. Friendly and helpful staff, same thing. Family friendly place is another point. Excellent service is another. And again, if you see this one, right, you have family friendly atmosphere is coming again. So create family place and create friendly atmosphere. They both are related to family and friendly atmosphere. I have not given this as a input that you classify this into one of the labels. It has automatically generated these classification labels for me and classified the text or the points on its own. So this is what we have done for the good points as well as the bad points, and basically mapped all the points together. And then what we have done is using this uh, standardized label, we have basically mapped all the comments or all the pain points and the good points in those labels. That's how we have standardized all the labels. So now you have limited number of responses for each of the comments. Payment, if you want to see, you have these things available. Let's say this one, inattentive service. What all comments said about inattentive service? So you have inattentive service, you have lack of customer attention, you have poor customer service, you have worker not attentive. Everything will come under inattentive service. So this way we have basically standardized the entire uh, comment section for us into specific groups. Now you can do a clustering on this, you can do a classification on this, or later on if you want to do a regression at some point later, you can do a regression also on top of that. So that is the basic use, basically how you can convert uh, text data into useful classification data using LLMs, where you don't have a previous understanding of the domain or the NLP specific parts. Same thing you can do using NLP, of course, and probably it will be slightly better than what you have with this uh, raw execution. But again, that will require a certain domain expertise and certain NLP expertise as well. Then I think let's move on to the second and the last application. Second one, which is second, yeah, documentation generation and code flow. So for this, uh, you must have already gone through this thing, or you should go is put your entire code on ChatGPT and ask what the code is all about, right? Now, when you're building the code locally or when you're building the code, let's say during your college, it is fine. But for industrial application, it is not, because code are proprietary and code are part of the organization's private data. So you cannot directly put them on ChatGPT or Claude or anything like that. So the idea here is to make the documentation of the code locally, and also give a good explanation of the code locally. So let's say if I'm a Python developer, but I want to use certain C++ dependencies or certain outputs from C++, I will not be able to read the code from C++ directly, but at least I can read the markdown file and understand what the code is taking as an input and what it is giving as an output, and can I use that output directly for me. So that sort of understanding, if LLM was not available, I will have to uh, go through the code line by line, understand what's the input, what's the output, and if the code is 2000 lines, it's a different ball game altogether. But LLM solves that purpose for me. LLM can read the code very nicely, understand its implementation across languages, and if you're good enough, you can build a RAG on top of the documentation that the code has already generated. So tomorrow, let's say if your code base has 2000 uh, code files, and if you want to know if your code base has a certain functionality available already in some location or not, then you can build a RAG application on top of this documentation generation which we have done. So for this, I don't have the code locally, but um, I have it on my GitHub. I can take you through it quickly. Yeah. So again, it quickly gives you the understanding of making a Docker Compose file, uh, which basically orchestrates a Docker and prepares multiple containers locally, which are talking to each other, managed by Docker Compose. And if you are using a GPU, as a separate one. If you are using a CPU, it's a separate one. You have requirements file, the markdown creation Python script, and the shell script. So ultimately, if you just run this shell script, the tool will take care of the shell script will take care of everything. Basically, check if you have if there's GPU available locally. If there's GPU available, then it will run this Docker Compose. If not, then it will run this Docker Compose, and then it will install the Olama on your system. It will pull in the model. Currently it's going, I think it's going, yeah, it will pull in the model, and then it will also do a local validation if all the containers. So this is a multi-container system where the containers are talking to each other using local host, local port, and it will basically tell if the containers are talking to each other properly or not. And you can validate it by hitting, let's say, this one, and it will give you a response. Then comes the creation part, the markdown creation part. So you can directly do this. You can give a directory where your GitHub or where your code base is present as a directory input, or you can give a single file also as an input, and it will basically check if it is a directory or a file, and based on that it will execute the document generation. You have some additional arguments, for example, files which you don't want to include, let's say git ignore file, or directories which you don't want to include, the pycache, the git, or this part, the thinking part. So for this one, what I've used is the LLM thinking, um, which is available, I think, in most of the tools now. So you have this thinking part. If you want to mention or if you want to store those thinking files also, you can do a true or false. The output looks like this, and you have a thinking file and you have an explain file. The explain file is the actual file which has the code base understanding given to you. So it will read the code base, it will read the Python, C++, any file, and will tell if it is what is there in the code. And you can go through it. uh, you can go through the code, uh, I mean, indirectly via going through the markdown file itself. The reason I've kept it in markdown is basically markdown are more native for LLMs to understand, and markdown also serves as a good practice for us to visually see the data or read the files differently. So you have different headings, you have different lines, you have separate boundaries like that. Again, this is the overall idea around this. Uh, it's a very simple Python script. It reads all the files inside the directory, and this is the part, I think, yeah, this is the part where you hit the LLM, the coin 3 locally again, because we have used Docker to deploy it locally. And this is the response request part, which the API part, which I was talking about, right? You're consuming an API in this case, right? And then this one basically gives you the prompt around that LLM and how to store that output. And this is basically the execution, the parsing part of the argument parsers. So very simple code. I think you guys can give this a try, see how it goes. One of the key skills, another key skills from a application perspective, from an industry perspective, is to be able to read a GitHub repo and execute it flawlessly. So you can give this one a try and see if you're able to execute everything from your end. Yeah, I think that will be all from my side. If you guys have any questions. Okay. Let me take a quick break and hello, ma'am.
Hello. So it is really very insightful. Lots of learning for me as well. Thank you so
Thank you.
much. I
Thank
hope
you.
everyone enjoyed the newer technology with the hands-on.
Yeah.
And you'll be giving this code book, notebook to the participant in terms of Canvas uploading.
Yes.
So they can see it later. Yes.
Yes. I've
So I wish
already.
that you go ahead, take this notebook and at least run it once so
Yes.
that new ideas will be coming up. And
True.
that's what
True.
we are here for, getting the new ideas. How do we do
Yes.
it? So many times it happens that you know the theoretical part, but practical aspects you lack.
Yeah.
So it's a very good idea. So happy to learn so many things. Thank
Thank
you
you,
so
ma'am.
much.
Thank you so much.
Yes.
Actually, this is my initiation, and I mean, great push from Satin sir also, because he understands that there's clearly a lot of difference between the textbook implementation and the actual industrial application.
Yes,
And I
I
think,
agree. Yeah.
yeah,
It's a big difference
this
actually.
this helps a lot in bridging that gap. So thank you to both of you. Thank you for this opportunity.
And where do you stay, Devanjan? From where are
Currently
you?
in Bangalore, ma'am.
Okay, okay, good. So otherwise, whenever you come to Jaipur, please interact with our students as well. They
Sure,
have
sure.
opted generative AI tools this time.
Oh, wow. Sure.
So this is the question in chat. Sir, can you show to how to clone the GitHub code directly using Google Colab?
Google Colab, I would suggest you not do that. You can do that using the Shift-1 or Shift-1 Google Git clone, you clone repo. But I would rather suggest you clone the repo locally and then you upload that as a directory in your Google Drive, and then you can pull that drive in your Google Colab. That will actually be better and safe, because sometimes the repos may contain some malicious code, and I mean it's not a preferred way of pulling code into Google Colab. Yeah.
So I request Dr. Satyendra, please ask everyone to turn on their video so that we can have a picture together with the expert. Dr. Satyendra, can we do it? We can't do it. Participants on नहीं कर सकते. अच्छा. Right. कोशिश करके भी नहीं ऑन करवा सकते कि हमें करवाते तो सत्येंद्र हम कर सकते हैं क्या इनको वीडियो ऑन करने का कुछ कर सकते हैं चीज यहाँ से
ऑडियंस के लिए मैं
हाँ पार्टिसिपेंट्स के लिए
वीडियो ऑन तो नहीं बट वी कैन अनम्यूट देम so participants can raise their hand and then we can unmute them
and one मतलब at a time one can on their video
so at a time one can on so once who want to share his feedback for the course he or she can raise their hand and then we can unmute them from here.
Okay, so we have reached to the concluding session, that is a valedictory. So you would like to be means take the quick break or shall we continue? Participants, you can raise the hand or you can write in chat box if you would like to say that you want a quick break or for 5 minutes, or shall we continue with the valedictory function? Continue. One is continue. Okay. Okay. So सत्येंद्र आपका वीडियो टर्न ऑन कर लो, हम लोगों की तो एक फोटो ले लेते हैं जो लोग देख रहे हैं. Yes. 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 So this FDP started on 5th of March. This was the day 1. It is of 40 hours course and around 157 participants registered for that. But somehow everyone couldn't continue, only a few. So happy that they were continuous, they were having the consistency. Almost everyone attended the full time. We have attendance and we did 2 quizzes. We have good grades also. So they will be getting the certificate on the basis of their attendance and the performance. That is a good, average, very good or excellent. These are the 4 grades we are going to give them. And I'm very thankful to the Professor Vineet Saula, sir, Chief Investigator, EICT Academy, who has given the opportunity to conduct this one, this FDP. That is the need of the hour actually. And we started with the basic NLP to reach to this today's lecture by the budget from the industry perspective. What are the challenges? How do we do it actually? So from basic NLP to agentic AI, and everything is covered, and all the material has been uploaded on Canvas. So if you have any issue, all the participants, please write in chat that everything what I'm saying is you are getting it on Canvas. So we have your attendance on WebEx and the quiz marks is on Canvas. So I'm thankful to Devanjan Mishra from Earthspace, Rohit Shukla from Footprint, Professor Manjulata Joshi from Purnima. She talked about low resource language. She worked in Hindi and showed so many ideas that how do we reach to the different languages. I'm also very thankful to Professor Satyendra. He is my colleague and he took mostly he covered the things and his team also. Mayank and Harshit. And my team, means MNIT team is Rashi and Ruchika. They were always there with us. And I'm thankful to Manish and Ramesh Babu Madula. They are the EICT research team. They were always helping and supporting. So, yeah, anything you would like to say? I request Satyendra to say something or
So
last
I think if participants wants to share their feedback about the this course, please raise your hand so I can unmute them, or you can write your name on the chat. I will unmute mute you. Anyone wants to share some few words? Any constructive feedback you want to give about the course? Okay.
सत्येंद्र, आप ऐसा करिए, जितने हैं आप एक एक करके अल्फाबेटिकली सबको अनम्यूट करते
No, so
जाइए.
Amit
Let them
is
speak. Let them speak.
Amit wants to say something. So
Yes, yes.
yes,
Yeah,
yes, Amit.
thank you so much, Satyam sir, for giving me this opportunity. I would like to thank everybody, all the distinguished professors who have shared their knowledge, and this would help us to strengthen our understanding of the NLP, and we'll be able to utilize them in the practical situations also. So it was a great learning experience, and I want to thank all the professors for sharing their knowledge. Thank you so much.
Thank you. And meanwhile, just an announcement. Within few days, so as soon as possible, we'll release the certificate to the participants who have completed all the criteria regarding the attendance and the quizzes. And also, if anyone of you have missed quiz 2, we will open it today for 2 hours from 7 to 9 p.m. So anyone else who wants to say something?
Randomly, you can unmute someone and request them to speak. So this is being recorded. Your feedback is very important for us, for EICT Academy. So please speak something. Maybe it's not always good feedback, maybe constructive. It may help us in the next FDP we are going to conduct. Even you would like to attend something that is not yet done, you would like to say something. कोई ऐसा कोर्स जो आप करना चाहते हैं, that is need of the hour, आप बताइए हमें. It's not exactly the feedback on this one. आप
Yes.
कुछ और भी बता सकते हैं.
So you can write to fdp.academy @mnit.ac.in, or you can contact ma'am as well, and you can write to me as well. So if you want to have a similar kind of workshops and FDPs on these topics, and then any other topics that you think ENICT should come up with that course, and then ma'am and the team can organize us FDPs for you. So I have made all the participants as a panelists, so they can directly unmute themselves, and then they can say if you want to.
Now they can turn their videos on. Being a panelist, they can turn their videos on.
Yes, so we can have a
Group photograph as well.
Devanjan, you can stop share. You can stop your sharing your screen. So yes, so please, those who can, please show your videos so that we can have a
So
photo.
it was nice to see Nitish. Please turn your video on again. Would like to have a group photograph. Yes, yes. Please continue. Khushbu, Nidhi, everyone is requested to please turn their videos on so that we can have a group photograph. Priyanka Gupta, Dr. Hina, Dr. Rajendra, Dr. Mirza, Dr. Srinivas, Dr. Umesh. Thank you, those who could do it.
So I'm taking a screenshot
Picture related.
of it. Yes. So I took one screenshot and one photo as well from the camera as well. Okay, I think so. Thank you.
Thank you, everyone. Yes, we can conclude it. Thank you so much for attending, for your patience. Hope everyone has got some or other takeaway. Keep working, keep shining. Thank you so much.
Thank you.
Okay, thank you, Devanjan. Let's close this session. I'll call you after
Sure.
some time.
Thank you, sir.